Now that we know something about the nature of lists in R and how to create them, let's go back to our sensitivity analysis and use a list to collect the results of our analysis before we save it. If I go to our sensitivity analysis project, I can open up RStudio using the project file. Once RStudio is up, I can go to our analysis.r script that we've been writing. And here is our analysis. Now, this is a pretty simple analysis so far, and it doesn't take very long to run, but sometimes our analyses get a lot more complicated and take quite a bit more time to run. So ultimately, what we're going to do is make a graph of our analysis. And if we're playing around with making a graph, we don't necessarily want to put that in the same script as the analysis itself, because then we'd have to rerun the analysis every time we make a new graph. So a lot of times you want to break your workflow up or break up a pipeline so that you are doing different steps with different scripts. And in that case, you want to save the results of one part of your analysis before you move on to the next part of your analysis. So that's what we want to do here. We've got our script, we've done our analysis. Now let's create a list in R. I'm going to call this list results because it's going to contain the results. Oops, there we go. There's going to be several items to this list, so I'm going to break this line of code up into several lines where I am going to put each argument to list that I'm creating on its own line. And the things I want to keep track of in terms of the rates of this, or I'm sorry, the results of this analysis is the rate coefficient. And that's going to be the name of this item, and that name just happens to be the same thing as the variable that I call it. So the variable in this script is called rate coefficient, and I want to assign the value of the rate coefficient of this variable to the rate coefficient named element of this list. Now when I do this, I always hesitate because I don't want you to confuse you to think these two things have to be the same. This is going to be the name of the element of the list, and this is a reference to the variable that has the value that I'm assigning to that name. So if you see R scripts, these don't necessarily have to be the same thing. I could be assigning this value to something, to a name of an element of the list that I want to call it something different. But in this case, it just happens to be the same. I want to do the same thing with the initial concentration. And then I want to do this with the vectors for times and the vectors for my results, including the concentrations and the filtered concentrations. So I can say times, the times named element of the list is equal to the times vector. The conses element of the list is equal to the conses vector. Finally, the conses filt element of the list is equal to the conses filt vector. So let's see if this runs. Okay, I didn't get an error. Now we can take a look at what's in results. If I just type in results, I can see I have a list with an element called rate coefficient. There's a single value vector of values in here with the value of 0.1. I have the initial concentration. Again, there's a single element vector, numeric vector here with a value of 50 in it. But for times, I have multiple elements. So here I have a list where one of the elements of that list is a vector of values. Also, I have conses, and these are the concentrations corresponding to these times. So this should be the same length in terms of 121 elements as I have in my times vector. And finally, a conses filt element with those values. And they're all in one object called results. I can convince myself that this is indeed a list by doing a type of on results. It is indeed a list. And as we've talked about, I can look at the names of the elements of results. With a shorthand, I can use names And these are the names of the different elements: rate coefficient, constant at times, constants and const fills. Or I can get to this using the attributes function on results. And the names element of the results list will give me the same thing as using the names function. Perhaps we should comment our code. Construct a list containing the results of the analysis. And finally, we can confirm that we can get to the individual elements of this results list. So if I need to get back to just the vector of times, I can either use the $sign to get to the element named times, and that gives me a vector of values representing the times from our analysis. And remember, this is the same thing as using the double square brackets, saying that I want the contents of a given reference, and I want to use the named element times. And that will give me the same thing as using the $sign operator. Remember that if I use single square brackets for this, it's going to give me another list with a single element in it. In this case, it's the times element that is that vector. So remember, the double square brackets is giving me the contents, so I get a numerical vector. But when I use the single square brackets, I'm getting the reference to that numerical vector, which means I'm going to get another list with a single element in it. And finally, if I look at names of results, I can see that times is in the third element. So another way I can get that vector is to go to results and the third element, and that should also get me those times, but giving it by the numerical index of the third element of this list. So that's just a quick review of all of the different ways that you can index a list to get to the particular components of that list.